In this lecture, we're going to explore some problems that might come up if you have a lambda function in a member function of a class and you try to use the member variables of that class. And we're going to see solutions to that. We will start with this simple example here. We have a class, and this class is going to have a simple member variable which is named creatively some member function. Inside our member function, we're going to have a lambda function. And this lambda function is going to try and have access to the member variables of the class here. Now, some of you might go on and try to create an object of this class and try to call this member function, but you are going to get a compiler error that says that you shouldn't really be able to access member variables from a lambda function, which is inside the class like we are doing here. So what is wrong here? Well, the problem is that by default, a lambda function doesn't have the this pointer from the class captured, and the C++ compiler doesn't have a way to access these member variables because it doesn't have access to the this pointer. We can solve this problem by capturing the this pointer in our class, and we can do something like this. And this is going to make this work because now the compiler has access to the this pointer from the body of this lambda function here, and everything is going to fall in place. If you think about how lambda functions are modeled behind the scene, the compiler is going to set up a functor which is really going to model this lambda function here. And to be able to access these member variables from that functor object, there needs to be a connection between this object here with the functor object. That's why we need to capture the this pointer to be able to use the member variables from this class here in our functor object. And if we do this, everything is going to fall in place. Everything is going to work just fine. Another way we can solve this is by capturing everything by value. And this is going to also capture the this pointer, and this is going to work. And we're going to explore this in a little more detail in Visual Studio Code. Here we are in our working folder. The current project is capturing the this pointer. We will grab the code from our template files and put that in place. And we will open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file that we can clean up a little bit. We will set up our item class here. So this is going to be a simple class which is going to have a bunch of member variables in. We will set up a member function called some member function. And inside this member function, we will set up a lambda function, which is this little guy here. And inside our lambda function, we will try to have access to the member variables of the class where we have this lambda function here. And you see that we have a bunch of squiggly lines. This is a good sign that this is a recipe for a disaster. Something is really wrong here, but we will be stubborn and ignore the squiggly lines here and try to create an object of our class. So we can go down here and say item and say item1. And we can pass in the data. What do we need to pass in? A bunch of integers. We can pass in 10 and 20. It doesn't really matter. And what we want to do is call our member function on this little guy. We will do something like this. You will see that we have a bunch of squiggly lines in here. If we ignore these little guys and build the project anyway, we can use our GCC compiler, which is our favorite. We're going to see that the build is going to finish with errors, so this is bad. And if we go in, we're going to see a bunch of messages from our compiler. This was not captured from this lambda function. So the lambda function is in the main CPP file at line 13. If we go here, we will see the body of the lambda function. This is the offending line. So the problem is our lambda function doesn't have a connection to this class here. And if we try to do something like this, everything is going to blow up because the compiler won't know how to access these member variables from this lambda function here. So we really need a way to connect this lambda function to the member variables that we have in this class. One way to do this is by capturing the this pointer explicitly. So we can do something like this. If we do this, our lambda function is going to have access to the member variables because behind the scenes, the compiler is going to go through the this pointer to access member variables anyway. So what the compiler does is something like this. We can say this and do mvar1, and we can say this and do mvar2. Now if we build our code, it should work. at least I hope. You can see that now the build is good because our Lambda function has access to this pointer, and you can think of this pointer as a connection between the Lambda function and the class object whose member variable we are trying to access here, and everything is going to work just fine. We can even remove this pointer thing that we have here, and the code is going to work just fine because the compiler is really going to try and use this pointer behind the scenes. So if we build our program again, we are going to see that it is going to work without a problem. And if we run our code, let's try to bring up a terminal window. And if we clear and run Rooster, we will see that our member variables are 10 and 20, which is the data that we passed when we created our item here. Everything is working really fine. Another thing we can do to get access to this pointer is by capturing everything by value. If we capture everything in context, we will also have access to this pointer, and everything will be captured by value. And if we build again, the code is going to work without a problem. So let's see this. And you see that this is really new. I just learned about this here, but implicit capturing of this pointer via this thing is deprecated in C++20. So we have no business doing this in C++20. The syntax that is recommended is explicitly capturing this pointer like we have done before, but this was a thing in older C++ code. You need to be aware of this. So let's pass our code through our compiler. Everything is going to work just fine. And some of you must be asking, what if I capture by reference? Let's try to capture this pointer. Let's try and capture everything by reference and see if this works. Let's try and build. We're going to build everything, and you're going to see that the build is going to be good. If we capture everything by reference, we will also have access to this pointer, and we can use it to access things in our C++ program. And you see that now we don't have a problem using an implicit capturing of this pointer if we capture everything by reference. And this is really interesting. If you want, you can explore this a little further and see why things are set up like this in the C++ standard. But I am just interested in telling you about the fact that you need to capture this pointer in your Lambda function to have access to the member variables of the class object where the Lambda function is set up. And you need to do this to be able to access these member variables from the body of your Lambda function. If you want, you can pass this code in CPP Insights and see what the compiler generates behind the scenes. That's a really good way to learn, but I am not going to do that here. The main message was that you need to capture this pointer to have access to member variables from your Lambda function. Another thing I want to bring to your attention is that if you capture this pointer, the Lambda function is going to have access to everything in your class. It is going to have access to public data. It is going to have access to protected data. It is going to have access to private data. And the Lambda function is basically going to become like any other member function because it has the key to everything you have in your class. And that key happens to be this pointer. You need to be aware of this. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about std function, a really cool thing that is going to abstract away any kind of callback you might want to use in your C++ program. That's going to be really cool. So go ahead and finish up here and meet me in the next lecture.